Welcome to Comet Computer Private Limited e-learning program of Network OSI Reference Model. So today we are going to discuss about OSI Reference Model. We have 7 layers available in the OSI Reference Model, as well as we are going to see the comparison of OSI with the TCP/IP model. OSI is Open System Interconnect. So this is a system formatted for having a common standard among the uh, network devices in the industry to give standard infrastructure details for the manufacturer so that it can have standard environment and it will be able to communicate between the devices. Prior to this, so we had different type of manufacturers manufacturing the um, devices for their own standard. So what happened is we are not able to interconnect or communicate between the devices. Same IBM is having a different standard and Intel is having a different standard. So Intel is following Ethernet architecture. IBM is following token ring architecture. So if at all I want to communicate between them, it is not possible to communicate. So I have to make it as a international standard so that the manufacturers, the developers will follow it and develop a standard environment so that multiple people can communicate globally. We can connect. So that is the reason for bringing this OSI reference model. And as part of ISO organization standardization, this has been brought in, and this is helping the manufacturers to follow the standards and manufacture the devices. So we are able to adapt to our latest devices from any other manufacturers. Also, same company is using a Cisco router, and if at all they don't want it to use for some reason, they can have a Juniper router or Juniper firewall wherever it is possible, right? And I can also have a combination of devices in my organization, multiple Cisco devices in one site, and other site may have Juniper network devices. So I can establish communication between them. Even the VPN connections is possible to establish between the devices. So this is made possible because of this standardization. So that's the reason we have a OSI reference model, and everybody will be referring this standard for manufacturing the devices. Let us see the individual layers, what is that available with the individual layers and what is the purpose of it. So it will be helpful for your ccna exam. They'll ask what is the protocol used in this layer and what is the format of data available in that layer. So I'll give you a summary. So if you remember that summary, it will be benefit for you for interview purpose as well as for the examination purpose. So this is a short form of OSI formation. So we have 7 layers. So maybe from top to bottom or bottom to top, you can remember it. It will be easy to follow it. First one is the physical layer. Here, the communication happens with the help of cables and connectors. It will be in the form of electronic signals, and it will be connecting the devices using the physical layer. You have coaxial cable, Cat5 cable, UTP cables, right? So different types of cables and connectors, BNC connectors, RJ45 connectors. So those things are used for connecting the devices physically and passing the signals from one system to other system. So function is manages signaling to and from physical network connections between the systems, between the network. It is helping us to communicate between the devices. The standard protocols used are Ethernet protocols, token ring, or Wi-Fi. If at all we are connecting via Wi-Fi, so those physical layer protocols will be used in this layer. The second one is the data link layer. Here we are maximum dealing with the MAC address of a device. So each device will have a unique MAC address. That will be very unique compared to IP address. MAC address is a unique one where it is given by the manufacturer while manufacturing, and it is being standardized by the organizations, right? International organizations. So each manufacturer will be given specific range. So in that only they'll be manufacturing the adapters. So whether it is a motherboard or a dedicated network card, so everything that will be a unique one. There is no possibility of duplication. So that is how the MAC address is built. And in data link layer, we'll be referring the MAC address. So there is a protocol available called ARP, Address Resolution Protocol. It will be playing a major role here to convert the IP address into MAC address for the benefit of system to understand, right? So in case of switch, that is a L2 device, it is maintaining a switching table. So mainly it is populating the data with the help of MAC address. So that is very important. With the help of MAC table only, switch is communicating the data from one system to other system, and it is not going for any broadcasting, right? So if I have source MAC address and destination MAC address, I can find out from the table in which port it is connected, and I can hand over the data directly to the particular MAC address. So that is helping us to speed up the communication, right? So here MAC address plays a major role for reducing the collision and broadcasting. So here you have a MAC address, which is also called as a physical address because it is physically written. It is not a logical address like your IP address, because logical address means it is being assigned by server. Maybe after 8 days it may get changed. But this is a physical address where it is like written by pen or pencil, right? So it cannot be changed by anybody from the network. So it is permanent. So that is the MAC address. So you have L2 devices available, layer 2 devices available, switches, bridges, WAP, that is wireless access point, network interface cards. So all the devices falls under data link layer. Specifically, switch also contributes something in the layer 3 part of OSI reference model. So we have L2 switch separately and L3 switch separately. So if at all you buy a switch without a console port, or that is a non-manageable switch, that is a L2 switch. And if at all you have a console port, that will be a manageable switch, and maximum that is a L3 switch only. Okay, so that is how we easily identify whether it is a L2 switch or L3 switch. The some of the protocols which is used in the layer 2 devices, layer 2 tunneling protocol, PPP and SLIP protocols, etc. So these protocols will be playing a major role in communicating between the systems. The third one is the layer 3 network layer. So this deals with the packets. So we are doing the encapsulation of information, right? From layer 1 to layer 7, there will be an encapsulation happening. Here we are adding some header information. So the entire frame is called as a packet. So we'll be going for adding that information. So once the data being received, the frame is being received from layer 2 to layer 3. In layer 3, we are adding some of the header information, and combinedly the entire segment is called as a packet. So here only we are dealing with IP addresses, and it is a logical addressing. We have devices like router, L3 switch, firewalls. So firewall will play a role in all the layers because it does the intrusive uh, packet filtering and other security related settings. So it will be playing a role in all the layers, but initially it was in the layer 3. Now it is working in all the layers. So some of the protocols, ARP protocol, IP protocol, RIP, IGRP, these are all the RIP, IGRP and all routing protocol. So ARP is a protocol used for conversion. IP, Internet Protocol. So that is available in the layer 3. Layer 4 is a segment. So here, along with the packet, I'm adding the layer 4 information that becomes the entire thing becomes segment. It is called as a segment. So here you'll have a TCP protocol, and it is used for communicating, right? So it breaks the information to segments and is responsive for connection and connectionless communication. So normally protocols we call it as a connection oriented and connectionless protocol. It means that connection oriented will always look for an acknowledgement, waits for the acknowledgement, and after receiving the acknowledgement only it transfers the data. Whereas in connection less, it will not wait for any confirmation, right? So I'll keep on sending the information. It will whether the destination is receiving it or not. So that is the difference between connection oriented and connectionless communication. So some of the hardwares are proxy server, gateways, and firewalls. And the protocols used here is TCP and UDP. So these are the major protocols used. Session layer, that's a fifth layer available. Once the information is transferred from layer 4, so here it is trying to establish a session between the systems or the endpoints wherever the communication is happening. So whatever data I'm getting it, so with the help of the data, I'm going to establish a communication with the other system and ensuring that end-to-end communication is happening and closing the requirement. Maybe doing a transaction through internet browsing or purchasing the product or copying the data from one system to other system. So it is called session establishment. Okay, so once the copy is completed, session will get terminated. So that is how it is being tracked. So it has the acknowledgements of data received during a session. So retransmission of data if it is not received by a device. So if suppose I'm not getting the acknowledgement, I will do a retransmission. It will have multiple try, then only it will get failed. So session layer protocols, you have RTP, SIP, NetBIOS. So these are all the session layer protocol. The sixth one is a presentation layer, where it is helping to have data presented for application layer, which is visible to us. So it is having the activity like data formatting, encryption, decryption, or compression, expansion. So all this activity will be performed in this presentation layer, where we are going to present the data to the user with the after processing in the application layer. So before that, whatever it is possible, the system format, it will be in the system understandable format. We cannot read it directly. It will be presented to the application layer so that we'll be able to read the information completely. So examples, JPG, MP3, MPEG. So the content you cannot read it, but only the output you can see in the application layer. So here it will be in the machine understanding format. So layer 7 is the application layer. Here only the data will be available in user understandable format, maybe a website, whatever you see in the computer screen, that is the overall information you are getting it, right? Application layer. So this is the layer where you can user can see and understand what is the data available, what is the communication we are going to make, and how we are going to communicate with other system, which system we are going to target. So all these things we will be doing only in this application layer. In turn, the system does a transaction of data. Now, if I do from layer 1 to layer 7, I call it as a encapsulation of data, and that is being presented in the application layer. If I send the data to other system, it will be in the application layer format. So one by one it is converting, and finally it is being reaching the endpoint, right? So that is a decapsulation. So this is the reversible process of encapsulation. So that is we are able to read the information in our desktop. Once I get the information, maybe sending mails, receiving mails, chat, website, right? All those things are example for application layer. So this is a summary where for easy understanding, what is the format of data we have and functions of each layer and protocols available in each layer. So after getting this OSI layer format, 7-layer format, TCP/IP protocol suite is prepared, and they have shortened with 4 layers instead of 7 layers, and that is used for being communicating into the entire network infrastructure. So TCP/IP is a combination of layer 3 and layer 4 protocol, set of protocols developed to allow cooperating companies to share resources across network. So with the help of IP address and with the help of TCP protocol, we are going to have communication between the system, because without IP address we cannot communicate, right? And without having the support of TCP communication, we will not be able to send the data, right? So that is the reason we are going for combining the both the protocols, TCP and IP, layer 3 and layer 4 protocols. So it is works best on all the operating system maximum, right? Whether it is a Linux, Windows, Solaris, whatever it is, these protocols are compatible with all the other operating system. So whether it is a different types of vendor also will not have any problem in communication. So these are the major four layers available. So they have clubbed it. Okay, so different type of layers. They clubbed it together and they shortened with four layers, right? So application layer, transport layer, internet layer, network layer. So three layers. It's a comparison, right? So application presentation session combined as application layer. And in the protocol suite, you can see what is the protocol available, and we can just make a note of it. So we have combined the usage of different types of protocols based on the usage in the real-time environment. And instead of transport layer, we have a host-to-host and transport layer. Instead of network layer, we have internet layer separately, different types of protocols used in that layers. Physical layer, we call it as a network interface, physical and data link combinedly. So we have different types of protocols available. So application layer protocols, we have FTP, Telnet, SMTP, and HTTP. So that is used for representing the information to the system, I mean user understandable format, right? So here only we can see what is happening in the system in the user understandable format. Transport layer takes care of end-to-end data transfer from one system to other system, one network to other network. And examples are TCP protocol. It is a connection oriented protocol which is ensuring that data is transferred completely to the endpoint and getting the acknowledgement. Whereas UDP is a connectionless protocol. It will be faster compared to TCP, but the guarantee of data transferred is not there. So, but in the real time, we use combinedly with the applications, right? So, based on the information, we'll be using different types of protocols. The next one is internet layer protocol. So this is internet layer protocol define the rules of how to find the routers for a packet to the destination. So here the routing is happening and it is helping for transferring the information and identifying the devices. You have IP, ARP, ICMP protocols. So normally ICMP protocols are used for doing the ping communication, right? If at all I want to know the remote devices available or not online, whether it is powered on and it's working fine. So the basic check how will we ensure is just do a ping of that IP address. If I get a response, I can understand that the device is online and it is working fine. If not, the device is out of network, powered off, or having some link related issue. So that is not in the network. So it will be very useful for testing the connectivity. So network access layer. So here you have a TCP/IP model combined. So mostly it is in the hardware. Well known it's a Ethernet adapter. So it will be used for communicating the data from one system to other system. So here Ethernet card plays a major role because through which only we are receiving the data to the endpoint, the systems. So other examples are Ethernet token ring, frame relay, ATM. So we have covered about OSI model and TCP/IP layer protocols, and here is the abbreviations whatever we have seen in the presentation for our reference and for ccna exam. This will be very much useful. Thank you. We have come to the end of the topic. Thank you very much.